My topic is facade systems and how can Ladybug be applied to achieve a more environmental friendly and comfortable architecture by optimizing the facade. Then the first one of this presentation is the workflow and the outline. Here is the workflow in the week 4 presentation. And for now, I improve the workflow as this, so you are including analyze, vote, test, and the system and output a summary. The first step is analyze, and then you can improve the placement and the nation. Then you can find EPW files from the internet. So after the purpose of the Ladybug, you will output environment data and the temperature. The Ladybug also could output some place the architects can use this to find the positive space of facade. Then move to the test. It should test the temperature of each facade and the surrounding architectures. The next step is model. Model the facade and the connections. You will move to the retest. You will retest the temperature in the surrounding and the connectivity, the daylight and the construction facility. Then move to the system. The system including simulation systems and the maintenance systems and the multifunctional systems. The multifunctional systems including the waterproof and the heat preservation. Then the final one is the summary. It will output an automatic system. Here is the timeline of this project. For the first step, environment analyze, you will use Python. Use Python to get the EPW file from the internet. Improve the placement and the nation name to get the location, because such as for Sydney, you have a Sydney in Australia and also have another Sydney in Canada. So the nation is very necessary for this Python code, and we can get the sun place and the temperature. The sun place including the 24 hours and the June, September, and December. You also could change the months to anything you want, and you will output the temperature, and from this sun place, the architects can confirm the positive space. Here is my first facade design in week 5. So my idea is use the different patterns to contrast with each other. And so the first facade designs, I divided the front facade and the side facade to adapt the environmental situation, and constructed these to test their temperature of architecture and the daylight. However, this pattern lack of the regularity and logically. So for now, my ideas improve to sending the surrounding architectures, because in the real life, the surrounding architectures will also affect the daylight. And use the two different building shapes. One is the box architecture, one is the organic one. Then I improve the sun place to the temperature of facade, because it more clearly shows the temperature of different facade sides. And so for now, my idea is the gradient facade. The first step is make one wall divided into many squares, and then find the midpoint of the squares. Scale these squares and increase the number of the squares from the bottom to the top. So you will shape a gradient pattern of a facade. Then when I retest this, the temperature of facade, you will may cause the different results. And for the construction feasibility, I designed a sandwich connections for this facade. So from these photos, it can show how these facade connections be applied, and it also benefits of the prefabricated building. Then there's some render photos of the connections and the facade. So for the non-organic architecture, it's pretty similar, but the connections of this facade are not complete yet. In the future, I will complete these two architectures of facades and then retest the daylight and the connectivities and the temperatures. And then it will move to the system and output automatic facade system.